gentlemen, this is your captain, and I'd like to welcome you aboard Flight 226. Looks like we'll be a little over 2 hours en route. We're currently cruising at an altitude of 35,000 feet. If you would like to take off your seatbelts at this time, please do, and enjoy your flight.
Radar's acting up. Tower, do you copy? Tower, this is 226. We've lost navigation. Repeat, we've lost navigation.
Solar storms are nothing new, but the truth is, we don't fully understand them, not even NASA, not yet. We live in a world of forecasts. We predict storms, chart flight paths, monitor satellites with second-by-second precision. But there's one force we still don't fully understand: the sun. Specifically, a region of the sun known as a coronal hole. It sounds harmless, scientific, but it's really a tear, an opening in the sun's magnetic skin where high-speed solar wind escapes and races toward Earth. Sometimes that wind merely paints the sky with auroras. Other times, it rips through our magnetic field, disturbs satellites, scrambles radio signals, and just maybe brushes against the edge of aviation. Now, NASA monitors this. They detect solar eruptions, they send out warnings, and most of the time, it's enough. But even NASA scientists admit something quietly. The model might not be complete, not wrong, but missing something, overlooking patterns we don't yet see. What if the next eruption isn't just big, but different? This isn't science fiction. It's happened before. In 2012, a solar radiation storm disrupted high-frequency radio over the poles, forcing commercial flights to reroute, thousands of miles added. Quiet headlines, quiet chaos. In 2003, during the Halloween solar storms, multiple satellites malfunctioned. Power grids in Sweden failed, and aircraft communication blacked out on polar routes, leaving pilots with no way to reach ground control for minutes. Airlines now avoid the poles during major solar events for this very reason. Not because planes fall from the sky, but because systems designed for certainty start to blur. Radar, GPS, HF radio, even cabin crew communications, and here's the kicker: the passengers never even know. Pilots are trained to handle outages. NASA sends alerts, airlines adjust, but none of that works if the storm hits before the warning. Imagine you're 35,000 feet in the air, somewhere above the Arctic Circle. The sky is calm, the passengers are asleep. But inside the cockpit, there's silence. The radar isn't responding. GPS is lost. High-frequency radio? Dead. The pilots switch to backup systems. They follow protocols. They stay calm, but there's no response from ground control, no satellite signal, no location fix, just empty air and static. These are the rare moments pilots train for, the edge cases, when tech fails. When instinct kicks in, when the flight is no longer a routine, but a test. It doesn't have to last long, maybe 5 minutes, maybe 15. But in the sky, that's enough time to cross hundreds of miles without a map. Now imagine if it wasn't just one plane, but many. And here's the truth no one likes to admit. We've built systems that assume certainty. We fly with GPS, navigate with satellites, communicate through frequencies that wrap invisibly around the globe, but those systems depend on calm skies. And sometimes, the sky has other plans. Solar storms don't ask for permission. They don't follow flight schedules. They don't wait for ground control to respond. They arrive, unexpected, invisible, and silent. And if even one assumption is wrong, if the timing is off, if the models are incomplete, Then for a few minutes, or longer, we're flying blind. Not because we didn't prepare, but because we trusted a sky we still don't fully understand. So the question isn't, can solar storms cause planes to crash? The question is, are we prepared for a sky that forgets to warn us? Because space weather isn't science fiction. It's the weather we stopped watching, and maybe the one we should fear most.